Hello, we are going to go over Unit 7 Trigonometry test review. All right, so have paper and pencil ready, have Desmos ready, and know your unit circle. Okay, so let's find the exact value of each of the following. Okay, the sine of pi over 6. Now, if you have a calculator available, you can just type in what is the sine of pi over 6. Now, be careful how you type it in. You have to put parentheses, okay? Like, whoops, like this. And we get sine of pi over 6 is 0.5. Now, the other thing is this. Pi over 6, if you want to look, all right, if we hit this and we do the circle, you'll notice that pi over 6 is right here, okay? Well, what type of triangle does that make? Now, if you didn't have a calculator when you do this, pi over 6, think about dividing the top portion into 6 and the bottom portion into 6. I'm only going to do the top portion because that's all I need here. And your triangle. All right. When I divide, think of this as being 180 into 6. I get this is 30 degrees. And if you remember, 1/2 and then square root of 3 over 2. 1/2 is across from 30. Square root of 3 over 2 is across from 60. And sine is y. Okay. The y is the up and down. Think about what's parallel or running along with the y-axis. And so this is 1/2. We just saw that on our calculator. Okay, now cosine of 5 pi over 6. All right, take your x-axis, that's just pi, divided into 6. Okay, so when I divide that into 6, all right, I'm going all the way around 1, 2, 3, 4, 5, all the way to there. Well, here's our triangle. Well, we just saw when you divide it into 6, this angle with the x-axis is 30. So across from 30 is 1/2. And then here, square root of 3 over 2. We just have to be careful that in this quadrant, the second quadrant, x is negative. So that is a negative square root of 3 over 2 right there. And cosine is x. So here, that's negative square root of 3 over 2. All right. Now, say you didn't know that and you're just like, okay, I just want to plug it in. And you can. All right. However, when we plug in the cosine of, put parentheses, whoops, 5 pi over 6, we get this decimal right here. And they want it to be written in exact form. All right. Well, here, as long as you know your different numbers for the points, like square root of 2, all right, divided by 2. Well, it's not that decimal. The other one is 1/2. Well, we know that looks like 0.5. And then square root of 3, all right, divided by 3. Well, I mean, not 3, sorry, 2. And like here, it's the same. It's just this one's negative. So it'd be negative square root of 3 over 2, like I wrote down right here. All right, let's look at number 3. Now, if you notice, these two were in radians. This is in degrees. So if you actually are trying to use your calculator, you have to make sure that you put it in degrees. All right. Otherwise, you're going to get an incorrect answer. So this is a sine of negative 225 degrees. Okay. So just, you don't have to put the degree symbol. All right. Oh, it's not. There we go. Okay. So 0.93. All right. So I don't know what that is. And did I change it to degrees? Nope. I did, but I reset it. Sorry. So I had to make sure it's in degrees. And how I knew is that wasn't one of the decimals we just talked about. So here it's like, okay, which one of those? There's only 2 that's going to create a decimal. Square root of 2 divided by 2 and up, it automatically is it. So this is square root of 2 divided by 2. Or we could do this right here. Okay, when it's degrees, now this is negative, so know that it's going around like this. All right, in the clockwise direction. I know when I go here, that's negative 180. And then when I add 45 more, there we go. Okay, when I add that's a 45 right there. I know you can't see it that well. All right, and across from 45s are the square root of 2 over 2, square root of 2 over 2, but the x is negative. All right, but here I'm looking for sine. I'm looking for the y value, so positive square root of 2 over 2. All right, and this right here. Okay, cosine of 3 pi over 2. If you actually look at the circle, all right, if I change this to the circle, all right, put it back into radians because that's in radians. You'll see that I clicked off of it. All right, 3 pi over 2 is right here on the axis. So when I draw it, 3 pi over 2 is right here. Okay, well, that when it lands on the axis, just think of the point. Now the radius is 1, and this is the point 0, -1. Y is negative right here. Now cosine is the x value. So the answer is just going to come out as 0 right there. Now, again, if you type in the cosine of 3 pi over 2, and this is in radians, just double check you're in radians, and you are, okay, it does come out as 0, which is what I have here. All right, so know how to find this. Okay, now for which angles is sine negative? All right, well, where is sine negative? So think about where sine is negative. Sine is talking about y. Y is negative in the third and the fourth quadrant. So as long as these show up in the third and fourth quadrant, we're good. Okay, well, the ones that are positive are okay. So let's look at this right here. Okay, so here, and let me move this for a second. All right, pi over 4. Okay, pi over 4 is when I zoom in right here. There we go. We see pi over 4 in the first quadrant. So sine is going to be positive. So it's not, I'm going to do this. It's not pi over 4. Okay, so let's look at 3 pi over 2. All right, 3 pi over 2. All right, let me zoom back out. 3 pi over 2 is right here on the axis. Now, remember, this is the point 0, -1. All right. If it's on the axis, you actually have to look at this. And sine is -1 here. Okay, so it is here. That's when sine's negative. All right, let's look at negative pi. All right, now pi, positive pi, is just when we go here. Negative pi actually lands at the same place, okay, where my arrow is. Same place, so it's the point 1, 0. Well, is sine negative or -1, 0? Is sine negative here? No. All right. The other thing you can do is, as long as it's in radians, if you don't have a clue, sine of negative pi. Is that negative? No, it's not. Okay. And then -13 pi over 6. All right. Here, -13 pi over 6. Did that come out as negative? And it does. All right. And then lastly, -5 pi over 6, or no, 5 pi over 2. All right. And that also comes out to be negative. All right. You could just plug that in if you want. Okay. Or you can figure out where these are. If they're in the third and fourth quadrant, that is when sine is negative. Now, where is cosine positive? Well, think cosine is x. Well, where is x positive? In the first and the fourth quadrant. So as long as these are in the first and fourth quadrant, we're good. Well, pi over 4 is in the first quadrant, so we're good. 3 pi over 2. Okay, so 3 pi over 2 actually lands on the axis. Okay, and is cosine positive here? You can actually really just look here. Cosine of 3 pi over 2. Okay, well, when I look at that, 0 is not a positive or a negative number, so we're not going to include that one right there. Okay, let's look at negative pi. All right, negative pi, again, it's this point at -1, 0 on the axis. All right, and here cosine is the x value. That's negative, not positive, so it's not that one. All right, -13 pi over 6. All right, and again, if you have a calculator available, you can actually plug this in. All right, cosine of -13 pi over 6. All right, just double check always that you're in radians when you're using radians, and degrees when I'm using degrees. And this comes out to be positive right here. Okay, and then the last one, -5 pi over 2. All right, just plug in the cosine of -5 pi over 2. And again, it's 0, and 0 is not positive or negative. All right, so it's not that. All right, let's look at number 7. The height in feet of the water in ocean is given by, so they wrote the function for us, where t is hours after 12 a.m. What is the difference between the highest and lowest water values? My suggestion is go graph this. All right. Okay, so you can graph this right here. You may actually know some things about it as well. And instead of t, I'm going to put x like that. All right, well, here, the highest and the lowest point. The highest point is here at 5, and then the lowest point is here at -5. What's the distance between those? And you can sit here and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just make sure each box is 1. So the difference between the highest and lowest water is 10. Now, here's another way to figure that out. Well, what's your midline? Your midline, there's nothing else added, is at 0. All right, so here, 5, that means I go up 5. All right, and then I go down 5 to -5. All right, and the total distance here is 10. All right, so that's another way to do it. And the question is, when is the water level at its highest? All right, so I'm going to go back to a graph. Where is it at its highest? Well, right here, its highest is right here at 1.5, when x, or t in this case, is 1.5. And then again, it's at 7.5. Let's see if we see any others. Okay, and then again at 13.5. All right, so we actually have several different answers here. When, okay, so yeah, we're looking at time. So all of these are when it's at its highest level. All right, its highest level. So 1.5, 7.5, and let's just think in a 24-hour period. Okay, so 24-hour period, it's all of these maxes right here. Now, these aren't the times. Remember, and so I don't need this one because that's after the first day. Remember, this is always after 12 a.m. Okay, so 1.5 hours after 12 a.m. is going to be, so 12 a.m., 1.5. Okay, that's going to be at 1:30 a.m. Okay, and I'll show you the answer in just a second, but it's 1:30. Okay, when I add 7.5, that's going to be at 7:30 a.m. All right, when I add 13.5, all right, that's 13 and a half hours. Okay, so that's going to be at 1:30 p.m. All right, and then 19.5 is going to be, so that's 19 hours, 19 and a half hours after 12. All right, so think about this for a second. When I add 12 on the 12, that's 12, but then I'm adding 7.5 more. So that's going to be at 7:30 p.m. So these are all the times when the water level is at its highest value. All right, moving right along. Which rotations with center 0 take P to Q? All right, and we've seen this question before, but it's a little bit different question. I know I've seen it as I've done some of these videos. Select all that apply. So you just need to know where Q is. Well, if you need some help, go look at the radian measures. Obviously, and what you got to do is go put it in the circle in radians. I'm going to take that off right there. And I'm going to hit the house button so I can see it. Okay, 3 pi over 4. 3 pi over 4 is right here in this second quadrant. It's not in the fourth quadrant. So it's not this one. Okay, 15 pi over 4. Well, that's not going to show up. So what you have to do is think about dividing this into force. Okay, force on top, force on bottom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is that where Q is? And it is. It's in that quadrant. It's just I went around twice. Okay, 7 pi over 4. Okay, you can sit here and find it on the unit circle, or you can draw it force. So 1, 2, 3, 4, 5, 6, 7. And that lands in the same spot. All right, now if I keep going around to 11, so this is 7, 8, 9, 10, 11. That ends in the second quadrant, so it's not that. And then this is 11, so let's go around to 23. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And it does. It's just, I keep going around. So we actually had 3 answers on this one. All right. Now, let's look at number 9. Match each equation with its graph. So this is a matching one. Now, we could start by graphing some of these if we wanted to, but we can also kind of do process of elimination. One of the things I notice is I could go find the midline here. All right, the midline here is y equals -3. Well, as far as a midline, remember your midline, it's got to have that -3 or -3 on the outside. The only one that does is this one. So this goes with B. All right, so the same thing here. Its midline is -2. Well, it's got to have a -2. The only one with -2 is this one right here. Okay, so this big B and little c go together. Now, the other ones, both of them have the midline of y equals 0, which both of these have nothing added off. All right, well, how can I tell the difference? Well, I notice this has a 3. That means your amplitude is 3. And if you notice, this right here is 3 right here. So from my midline to my max, or my midline to my min, is a total of 3. So that's my amplitude right there. So here, this one is D. All right. And then this one also, it's negative. Okay. This one's negative, so it starts, and because it's cosine, it starts below the midline right here when it's 0. Okay. So this one has to be A. All right. I didn't even have to graph it, but if you need to, go graph it. Okay. Say like the sine or negative cosine of theta, or you can just put x in. All right, now you would have to change it to where it's the grid like that. I'm going to hit that house. However, if you actually notice, and I'm just going to if you notice, all of them go from my x's 0 to 2 pi. Now the y's actually vary. Okay, here, this one looks like it only goes up to 1. So if you actually want to do like -2 to 2, you can. All right. And you see that this matches this last graph here. Okay, especially changing the window on it. That helps you out when you're looking and you're matching up graphs. All right, let's look at number 10. Hold on, I got a wire underneath this, so give me a second. All right, here we go. Now it'll stay steady. The vertical position in meters of the point P on a windmill is represented by this function right here, where T is the number of seconds after the windmill started turning at a constant speed. All right, how long are the windmill blades? All right, think about it for a second. The windmill blades, how long are the windmill blades? Every time we've done this, the windmill blades have a length of whatever our amplitude is. So think amplitude on this. So what is our amplitude? If there was a negative on this, we would take it off, but this is going to be 7. All right. Now, how many revolutions per second does the windmill make? All right. Revolutions per second. All right. This is like, and this can be very tricky. Okay. How many revolutions in 1 second? All right. Now, here, how long does it take the windmill to make 1 revolution? That is talking about the period. So if you were thinking this is the period here, it is not. 1 revolution is the period. Okay, I'm actually going to start with that one first. Remember, the period is 2 pi over B. And my B value equals 2 pi over 9. Okay, so this would be 2 pi divided by 2 pi over b, or 2 pi over 9. And remember this, whenever we have fractions, we change it to multiplication and we flip this. You can also do this in your calculator too, but here the 2 pi's go away and it's 9. All right, so it's 9 revolutions, or 9, I'm sorry, 9 seconds to do 1 revolution. Now, this question is how many revolutions per second? Well, if it's 9 seconds to do 1 revolution, then think the reciprocal. It's 1/9 revolutions in 1 second. All right, because that's kind of hard to come up with on your own. But if you come up with the period first, all right, this is 9 seconds to do 1 revolution. So how many revolutions in 1 second? Well, it's 1/9 of it. And then where is the midline of the graph? The midline, remember, is whatever is added or subtracted out here. So this is at y equals 15. You don't actually have to graph this if you don't want to. All right, now you can graph it if you would like. All right, and when I graph it, it is 7 sine of 2 pi x over 9. All right, and then we say plus 15. Okay, and here, okay, I can definitely tell my midline is y equals 15, and you can plug it in. Does that go through the middle? All right, think of this as a windmill, and right here would be the length. Okay, now as far as 1 period of it, that's c. Okay, do you see how 1 cycle of it goes from 0 to 9 right here? So that's the length of 1 cycle, okay, or the number of seconds it takes. All right, because T stood for seconds. All right, and so in 1 second, you do 1 over 9. All right, now moving right along. We got more to this. Okay, find the measure of each angle in standard position. Okay, -4, -4. So let's actually graph this right here. Okay, now if you want to graph it in Desmos, you can. All right, so -4, -4, just to see where that point is. All right, it's in the 3rd quadrant. Now what I'm going to do is I'm going to make the circle, because you want to know kind of like what is the position, find the measure of each angle in standard position. Well, where is this lying? Okay, this is lying on this line right here. And as I zoom in, do you see it's at 5 pi over 4? Okay, so that is at 5 pi over 4. Now, if I want the degree, I can toggle off and actually change this to degrees, and then I zoom in. You can see that is at 225 degrees. All right. And I said you can write it in either. All right. Now, what about this other point? 1/2 and -square root of 3 over 2. Now this, if you know the unit circle, okay, and where this is, you can find it real quickly. But if you don't, let's go put it in. All right, 1/2, okay, -square root of 3, all right, divided by 2. All right, look where that point is. Go put the circle on there. Okay, let's look at it in radians. And if you notice, that is on 5 pi over 3. Okay, so 5 pi over 3. If you want it in degrees, we can change it to degrees by toggling off to degrees, and we realize that is at 300 degrees. Now, if I'm doing this without a calculator, all right, think about where 1/2 and -square root of 3 is, and it's over here somewhere. Okay, and we can create the triangle. So the y value is 1/2, x value is 1/2. This is -square root of 3 over 2. All right, and that's where the point is. Now, across from 1/2 is the angle that's 30 degrees. Here is the angle that's 60 degrees. Okay, so here, think about when I go from here to here, basically 360 minus 60 is 300 degrees. Now, remember how we changed from degrees to radians? So if I had the degrees as 300, and I put it over 360, all right, then the radians, I'll put R over 2 pi. All right, and if we multiply each side by 2 pi, okay, and I simplify this right here, you're going to get 5 pi over 3. All right, and this leads us into the next one. Let's change each radians to degrees or degrees to radians. Now, 150 degrees, if you do have a calculator, do you see how 150 degrees is right here? If you want to change it to radians, all right, we just flip it to radians, and you see it flipped to 5 pi over 6. All right, or we can do this right here, kind of what we did here. 150 degrees, well, a whole circle is 360, equals the radians over 2 pi. And when I multiply by 2 pi, now notice I left pi in my answer. So here, if I take the calculator and I say, okay, 2 times 150, all right, and then I divide by 360, and then I change this to a fraction, that's 5/6, and I would just put pi with it. All right, now, I know the unit circle, and so this next one, 3 pi over 10, is not on the unit circle. All right, so degrees over 360 equals the radians, 3 pi over 10, over a whole circle, which is 2 pi. Well, here, pi's can cancel out. All right, and to solve for the degrees, if you just multiply each side by 360, all right, here, if I take it and I say, okay, 3/10, all right, that's divided by 2, but then I multiply this by 360, I get 54. So what that means is, and the pi is divided out, so I don't even need that anymore. This is the same as 54 degrees. So let's do this again. All right, I want the degrees, so a whole circle is 360 equals. Now they're giving me the radian measure is this, and a whole circle is 2 pi. The pi's you can just cancel out. All right, and I need to multiply each side by 360. Now you could simplify that first if you wanted to. You could say, all right, 5 over 18. All right, and then divide that whole thing by 2. All right, so you get 5 over 36. All right, and then you times that entire thing by 360. Not typing it right. And I get 50. So this transforms to 50 degrees. All right, now let's look at these graphs. Sometimes a calculator is not going to help us, and they're going to give us a graph that looks like this. All right, well, where's our midline? The midline lies right in the middle, right here. If it's the x-axis, it's just y equals 0. My amplitude is the distance from here to here. Now, I caution you because look, that's a 2, so this is going to be a 4. So my amplitude is going to be 4. And then what is the period? The period is the length of one cycle. All right. Well, here, if this is pi over 4, I just double that. So when I add pi over 4 to it again, and just think, what is 1/4 plus 1/4? All right, that gives me 1/2 or 2/4, which is 1/2. So this is going to be pi over 2. All right, let's jump to number 17. Kind of the same idea. Determine the number of cycles pictured in the cosine function. So from 0 to 2 pi. Okay, so 0 to 2 pi is this right here. Well, how many cycles do you see? Well, you only see one cycle right there. All right, now find the period. Well, the period is the length of one cycle. So if this is one cycle, the length goes from 0 to 2 pi, which is a total of 2 pi. And the amplitude, again, is the distance from the midline to the max, or midline to the min. And here, this is a distance of 1. So this is our amplitude. All right, number 18, midline. Okay, Midline, again, runs through the middle. All right. Now, if you notice the lowest point is 2, the highest point, lowest point is 0, the highest y value is 2. So in the middle of is 1. So y equals 1. Just be careful if it doesn't land like right there, like on a number. All right, it can happen. Now our amplitude goes from the max to our min. So this distance is a total of 1. So that's my amplitude. And my period means length of one cycle. Well, I'm going to highlight one cycle right here. All right, so one cycle goes from here to here. That length goes from 0 to 4 pi. So 4 pi is my period. All right, 19 and 20, we're writing equations. So in number 19, we're going to write a cosine function. All right, so we know we're going to have cosine. There's going to be some value out in front of it. Okay, there's going to be a b value. Okay, and then we're going to have x. And then there's going to be a k value. All right, now write a cosine function that has an amplitude of 5. Well, when the amplitude is 5, that's our a value. Okay, the period is pi. Remember, period equals 2 pi over b. This is our b value right here. That's not our period. So when our period is pi, you can solve for b. This is one way to do it. So if you multiply by b, b pi equals 2 pi. And then we just divide by pi. And if you notice, the pi's cancel out, so b equals 2. Now, another way to do it is the period, and we talked about this in one of my videos. Or actually, hold on. B equals 2 pi over the period. So here we could just jump to 2 pi divided by pi, and they just cancel, and B equals 2. All right, and one of the last things, vertical shift of 5, that's this number out here. Okay, it says midline or vertical shift. That is talking about that number that's added or subtracted. And here our a value is greater than 0. So what that means is that a value that I wrote down here is positive. All right, and then if you graph this, okay, just to double check it, always graph what you've read. 5 cosine of 2x, just make sure it's in radians. Make sure you put the 2x in parentheses. So I backed up and did that. Plus 5. All right, is our midline or our vertical shift, our midline should be at y equals 5. All right, here our amplitude, yes, is 5. All right, and our period, the period is the length of one cycle. So from one cycle goes from here to here. And you see that's a length of pi. All right, so we did it correctly. Now let's look at number 20. Write a sine function. So we're going to write a sine function. I need an a value, I need a b value, and I need a k value. So the amplitude is 2. It goes here. Now I'm going to jump to here. Do you see how it says my a value is less than 0? That means my a value is negative 2. All right, my period is 4 pi. Now, I don't care what formula you use. If you just want to use b equals 2 pi over period, so over 4 pi, you'll realize 2 over 4 is 1/2. So my b value is 1/2. All right, and then my midline is y equals negative 2. So I just put a negative 2, or you can put minus 2. So y equals negative 2 sine of, you can even have x over 2, all right, or theta over 2, and then minus 2 like that. All right. Okay, and we have one more page. The graphs kind of made it to where it was longer. All right, so let's go up here. Now, you can graph some of these and find them. Okay, so if I have this right here, okay, negative 2 sine of 4x. All right, and then minus 4. All right, now you may want to make this a little tighter right here. Okay, and zoom in. Let me use these. Whoops, doesn't know. Okay, zoom in just a little bit. All right. Okay, so here we go. Well, where does it look like the midline is? Y equals negative 4. All right, and that does split it in half. The other way is you see a minus 4, and I'm going to jump around on this. I like to start at the midline. Okay, from the midline, you can get the amplitude because the distance from this to my highest point. Now be careful. I've zoomed in. All right. So I can't just count boxes. Notice this goes from 4 or -4 to -2. Well, what's that distance? That's just a distance of 2. Now, another way you can get the amplitude is just take the absolute value of that number. So instead of -2, 2, it goes here. All right, vertical shift. Vertical shift and the midline are just the same thing. So -4, or we can say it went down 4. All right, and the period, 2 pi over b. So in this case, 2 pi over 4. Be able to simplify that. 2/4 is the same thing as 1/2, so pi over 2. Okay, or we can look at the graph and say, okay, what's the length of one cycle? So from here, okay, back to here gives us one cycle. And do you see my x value of pi over 2? From 0 to pi over 2, so that's the length of one period. All right, so let's move on to this one. Now, my midline. Midline is what's added or subtracted out here. I can definitely tell that's just 0. My amplitude is the number out there without the negative. All right, just 1/4. My vertical shift is the same thing as my midline, so there is none. You can say 0 or none. And then my period, remember, 2 pi over b. So this is 5 pi over 2. And so if you divide this, all right, when I divide it, you can take 2 pi and divide it by, I'm going to put in parentheses, 5 pi over 2. All right, and I get 0.8, or you can say 4/5. All right. Or we can go graph it. Okay, so when I go graph it, 1/4, okay, cosine of 5 pi, put an x, all right, divided by 2. All right, now when I go and zoom in, all right, let's look at this right quick. All right, my midline, is it at y equals 0? And it is. That runs through the middle. Now here, if you look, this goes all the way from 0 to 0.25. 0.25 is, or 1/4, is my amplitude. All right. Now remember, 0 is the same thing as my vertical shift. All right, and the last thing is my period, the length of one cycle. So one cycle goes from here to this max right here, and that's a total of 0.8. So as long as you start at 0 and then you end, that the length of it is that point A right here. All right, so moving right along. 23. Okay, if cosine of theta equals -square root of 3 over 2. Okay, cosine, okay, that would be our x value. Well, one of the things is this is negative. Okay, where's cosine or x? Negative. Well, that's going to be in the second or the third quadrant. Okay, so it's either in this one or this one. All right, now it does tell you theta is in between pi, and I know pi is here, and 3 pi over 2. So I just narrowed it down to the third quadrant. All right, so right here. Okay, well, think cosine, that's the x. Okay, well, think about our 30, 60, 90 triangle. That's where it had square root of 3 over 2. So that's -1/2. Well, across from 1/2 would be 30 degrees, right? Okay, so here, when I go all the way around to 180 plus 30 degrees, that gives us 210. Okay, however, you want it in radians. Now, you can transform this by doing 210 over 360 equals the radians over 2 pi, like I was doing earlier, or you can take the unit circle here and say, okay, when it's in degrees, 210 is here. All right, so when I change that to radians, that's 7 pi over 6. Okay, so 7 pi over 6 would be it in radians. All right, now find the length. Okay, this is going back to unit 6, but we reviewed it here in unit 7 because it goes along with trig. Find the length of an arc with radian measure. So length, when we're talking about radians, was radius times radians. Okay. The radius in this case is 4. The radians is 5 pi over 6. All right. Here, if you want to just, you can multiply it. We're going to leave it in terms of pi. But here, this is like 4 over 1. 4 times 5 is 20. And then you have 1 times 6, 6. And then a 2 comes out of each one of these. So that's going to be 10 pi over 3. So that's the length. Now, you can throw this in and get a decimal. It all depends on what it's asking for, especially if it's a multiple choice. All right. Or a short answer, and it'll be explicit. Now, number 25, if the length of an arc, okay, I'm seeing that length again, okay, and it's radius. So again, radius times radians. All right. So the length this time is pi. So they're giving you the length. I'm going to put that in for L. And the radius is 5. Okay, what is the measure of the angle? That leaves the radians. I'm going to write theta. Well, how do you solve for theta? You would just divide by 5. So pi over 5 equals theta. Theta. That's the angle or the radian measure. All right, number 26. Is the length of a minute hand on a clock is 10 inches. So you have a clock and the minute hand is 10 inches. That's like our radius right there. How far does the minute hand travel from 1:20 to 2:45? All right. And let's just assume this is like PM to PM. All right. Now, you have to know where 1:20 is. 1:20, remember we talked about the clock. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then there's 12. Remember, these are all 5s. So at the 1, it's 5, 10, 15, 20. So the minute hand starts here, and this is the length of 10. All right. Now it starts right here. Okay. And then think about it. If I go around, that's going to be 220. So I go around once. Okay. So I go around the length of 1 time. Okay. So that's radius times radians, or basically the whole. All right. So far I've gone 20 pi. Okay. This is 1 time around. All right. Plus, okay. And then I go around and I'm ending at 245. So this is at 220. Okay. So this is 225, 230, 235, 240, 245. It lands right here. All right. Well, what of the circle is that? All right. Well, if you notice, this is 5, 10, 15, 20, 25. Okay. If you want to think of it as 25 of the 60 minutes, you can. All right. 2 pi r. All right. So here I'm adding, and when I take my calculator, I'm just going to take this calculator right here. So think about this. 25 over 60 times 2 times 10. I'm not plugging pi in. So this makes 25 pi over 3. All right. But now I have to add 20 pi. So if I take this right here and I just add 20, that's 85 over 3 pi. That's the total radian measures, or the length that this hand went. It went around once, and then it went around 25 more minutes. All right. Okay. Now, Grayson put the tip of her pen on the outer edge of a graph. All right, of the unit circle at point 0, -1. Okay, so 0, -1 starts right here. She moved her pencil tip through an angle of 5 pi over 4. Now notice usually our unit circle starts here. All right, so let's just go look at 5 pi over 4 for a second. All right, 5 pi over 4 is actually in this third quadrant. All right, so I'm going to zoom out for a second. I know it's on this line right here. It's on this middle line. I know you can't see it right now, but I zoomed in to see it. All right, well, notice you go a whole 2 quadrants and a half. Well, right now I'm right here, 0, -1. All right. It's right here. So I'm going to go 2 quadrants. So go 2 quadrants and a half. And I want you to know where it, right here, that's where it's going to land. All right. And that's going to be, when I zoom in, 3 pi over 4. Okay. So it goes 5 pi over 4, which is this one. Okay. At what point on the unit circle did Grayson's pen stop? All right. This is at 3 pi over 4. Now, if it said the radian measure, we would end at 3 pi over 4. But the key is it says point. Well, here, anytime you have a triangle that has in the radian measures divided by 4, that's that 45, 45, 90 triangle where it's square root of 2 over 2, square root of 2 over 2, but realize the x is negative here. So the point is negative square root of 2 over 2, square root of 2 over 2. That's probably the easiest way to solve that right there. All right, and lastly, the amplitude of a periodic function is 4.5. All right, its maximum value is 7. All right, so here we go. Its max is 7. All right, what is the function's minimum value? Now think about this. The amplitude is 4.5. So here, to get to the midline, I would subtract 4.5. So 7 minus 4.5, and I get 2.5. This is our midline right here. Well, so this is our max. Well, to find our min now, you would have to subtract another 4.5. Okay, so let's subtract 4.5 from here, and I get -2. That tells me my min is here at -2. All right. So remember, your amplitude goes from your max to your midline, and then your midline to your min is another amplitude. Okay, so you kind of have to do that twice. So if you really just wanted to say, okay, if I did that twice, that'd be 9. 7 minus 9 is -2. All right. Review back through this. You have your test. Trigonometry can be difficult. You do have to be very familiar with your unit circle because Desmos doesn't give you everything. It doesn't give you the points on there. So you have to be very knowledgeable of it. All right. This is our last big unit. Make sure you've reviewed a whole bunch of stuff. Get ready for this test. And then after this, we'll be kind of in review mode for the EOC. But we do have a little bit more on statistics to go over as well. But we're close to the end. So good luck on your test and do your best.